So as we continue working with ratios and rates, we are going to look at some applications in section 1-2. Here we are looking at scale drawings, and so we can talk about what's called a scale factor. For a scale factor, we're going to look at the car to the drawing. So the car is 198 inches, and the drawing is 4.125 inches. And then you can keep simplifying this down. So 72 inches to 1.5 inches. And that gives me a common ratio of 48:1. Okay, so this first ratio is doing my long side of the car, and this second ratio is actually doing the short side of the car. And so they should be equal. You can't have a mix of a different ratio or scale factor when you're looking at something like a car to a drawing. So in general, when we talk about similarity, we say that objects are similar if they have the same shape but different sizes. So you can see here that the blue set of triangles are the same shape, they're just different sizes. But if you take a look at this second set of triangles, the shape changes a little bit when you're looking at this leg. So this is not similar. So the ratio of corresponding sides of similar shapes are proportional. That means that if I have different size shapes, that I can still figure out what those lengths are as needed. So looking a little more at similar shapes, the ratio of corresponding sides of similar shapes are proportional. So here we have with a rectangle, A over C, B over D. You could see this written a couple of different ways, but here we're matching A to C and again B to D. And then you can see the matchup of the irregular. So X to P. And these don't have to go in this order, but it's just working it around the figure. Y to Q, W to T, and Z to S. Notice that I always started with the same figure in each of those scenarios. So here we have an example. A prison is planning to build a new guard tower 140 feet inside the prison fence. The fence is 20 feet tall, so we know that this fence is 20 feet tall. And a spotlight is going to be at the top of the new tower, and it needs to reach to 80 feet outside of the fence. So how tall should they build this new tower? So the first thing we really need to do is figure out what is this entire side of the triangle, because what we're going to be comparing here is two triangles. The end of the light to the fence, and then the end of the light to the actual spotlight and back out. Okay, so if I have 80 plus 140, I get 220 feet. Okay, so we do not know how tall this tower should be. So if we look at that little blue triangle I made, then I have 80 over my height of the fence of 20. And then at my big green triangle, I have 220 over how tall does the tower need to be. Now you can solve this proportion. So we're going to just do, I'm going to add a page here. So again, I have 80 over 20 equals 220 over the height of my tower. So 80h, and then 220 times 20 gives me 4,400. Divide by 80. So h is 55 feet. So the tower needs to be 55 feet tall. So let's look at some proportions. There's direct and indirect. So we're going to look here at what is the definition of direct proportional. Two quantities are said to be directly proportional if an increase of one leads to an increase in the other. So that means they are going to be doing the same thing. So vice versa would be a decrease in one means a decrease in the other. For an example, if I have 1 gallon of a particular paint is supposed to cover 250 square feet, then how many gallons would be needed to have a cover of 1,800 square feet? So 1 gallon to 250 square feet, how many gallons to 1,800 square feet? You can solve this, of course, by cross multiplication. And then you're going to divide by 250, so 1,800 divided by 250 gives me 7.2 cans of paint, but we can't, gallons of paint, but we can't really buy a partial gallon, so I would say I would need to buy 8 gallons of paint, but the exact amount is 7.2 gallons. Now let's take a look at the definition of indirect proportion. So two quantities are said to be indirectly proportional if an increase in one quantity leads to a proportional decrease in the other. So when solving an indirect proportion, we do need to flip one of the ratios. So here let's look at two indirect proportion examples. And remember that we do have to flip the ratio. So if I have 3 workers build a wall in 12 hours, how long would it take for 6 equally productive workers? So the way I'm going to set this up is I'm going to do workers together and then my time, so my hours. Now keep in mind that the way, since this is an indirect, right, because we have 3 workers takes 12 hours, so if I increase my number of workers, it should decrease my number of hours. So that tells me that it's indirect. I'm going to flip, so the way they will match will be the numerator workers goes with the denominator hours, and then the denominator workers goes with the numerator hours. So I have 3 workers takes 12 hours. And how many hours does 6 workers take? And now we're going to solve. So 3 times 12 gives me 36. 6 times x is 6x. Divide by 6 on both sides. And that gives me 6 hours. Here we're going to look at a reservoir. It takes 14 hours for a faucet to flow of 18 liters per minute to fill a reservoir with water. So how long will it take if its flow is reduced to 7 liters per minute? So we know that we're reducing the rate, so then our time should increase. So I have my rate of flow, so 18 liters per minute, takes 14 hours. If it is reduced to 7 liters per minute, how many hours? And now we're going to cross multiply to solve. So 18 times 14 gives me 252. 7 times x is 7x. divide by 7 on both sides. So we're getting 36 hours when the rate is reduced. Here is some practice problems from your textbook, and please let me know if you have any questions.